Welcome. My name is Chiu-Ki Chan, and today we are going to talk about Advanced Android Espresso. In case you do not know, Espresso is a testing framework. So let me just back up a little bit and ask all of you, how many of you do Android testing? Oh, OK, more than half. That's excellent. And how many of you have written Espresso tests? Little bit less than a half. So cool. So this is an advanced Android Espresso, so I'll be going through the beginning stuff pretty quickly. But hopefully, for those of you who have not done it before, you'll still get a good enough overview so that when I explain more advanced techniques, you can follow along. Well, first, what is Espresso? In short, Espresso is an automated UI testing framework, meaning that you write some code, and then you can let go of your hand because Espresso will click buttons and type text and do all these user actions for you, and then you can verify the state of the app to make sure that it's behaving the way you expect it to behave. And what's nice about Espresso is that, well, first of all, it's a first-party library. It is written by people at Google. It's get delivered through the Android testing support library. And like I said, it simulates user action. So the program's actually clicking the button and then exercising your app that way. But the most interesting thing about Espresso is that it does automatic synchronization. That sounds really fancy, and whatever that means. So I can tell you what happens before Espresso came along. Before Espresso came along, there is already a way to do all these things, like click on buttons and verify. But the problem is that the click action that comes from your test app is not synchronized with your main app, meaning that your app may or may not be ready. So for us human, it's instantaneous, right? Like you open the app and the buttons are there. But it actually takes a few hundred milliseconds for the rendering to happen. And your test thread is super fast. So when I was writing tests before Espresso, what will happen is that I will say, go click the button. And my test code will be like, there's no button to click. And that's not because there's no button, it's because I was too fast. So that's what I mean by synchronization, is that Espresso actually have watches. It will watch over the UI thread and make sure that it's idle, it's done rendering before it goes try to click a button. And it also watches the async task thread pool. So if you are doing something in the background with async tasks, it will wait for that as well. So that's what's nice about automatic synchronization. Another way to put it is, I don't know if you've written tests before, and you have to make it sleep to make it pass, to do the synchronization. I mean, I make it sound like magic, but actually behind the scenes, that's what Espresso does. But it sleeps for you. It's not just, it doesn't blindly sleep for like 500 milliseconds. It's like sleep and wake up, say, hey, UI thread, are you done? Oh, you're not done? OK, I'll sleep again. So it makes it a little bit more intelligent sleeping so that you don't have to worry about it. So behind the scenes, there's still some sleeping going on. But at least you are not the one that's randomly guessing some random number of milliseconds to sleep. So I'm going to go through Hello World for those of you who have not done this before. Espresso kind of have a formula that is, I think what people call a fluent API. So there are three parts to this: on view, perform, and check. On view is the way to find a view on your app. So for instance, when we have this Hello World app, we have this button called Greet. To look for this button, we can use the with ID function. And we can give it the ID that says, look for the Greet button, OK? So now at this point, we have located the button. Now we need to do something to it. With that is view action. We can ask Espresso to then click on this button, and afterwards, we'll verify something. In our case, for some reason, you can only greet once. Once you greet, the button will be disabled. So once I click on the greet button, I want to check that it says check matches not enabled. So in Espresso, you can also combine different view actions and reassertions. So in this case, there's a built-in function called isEnabled that I can use to verify that the button is enabled. There's no function called isNotEnabled. What you do is you negate that. And I have actually published this under this GitHub repository. And like I said, the whole slide deck is already shared. If you go on Twitter, you can click through and find all these examples. There are a lot more coming, so don't frantically write down URLs. That is not the best use of your time right now. So like I said a little bit earlier, the with ID is something that Espresso provides for you to look for a view. There are other things like click, matches, and is enabled. So almost everything here is coming out of the Espresso library. But the not part is from Hemcrest. It's still bundled with the Espresso library, but it's not written by the folks at Google. It's a Java-specific library that you can do different things. So these are all the Espresso view matches, view actions, view assertions. And we're going to sit here the whole talk to go through each one of them, and then until you fall asleep. No, that's not the agenda. I'm just going to show you this because that's a cheat sheet online that you can go check if you are wondering what is the capability of Espresso. On top of that, like I mentioned earlier, there's Hemcrest. Again, cheat sheet, function galore. I'm not going to go through that, but you can go and you can take a quick look, and there's things like what I did already. Not is one of it, and then you can also do other things that is an instance of. So basically, Java level matching rather than Android matching. So with this, you can actually combine them, and it's going to become much more powerful instead of just a single one. So let's go through one example. Suppose I have an app that uses the toolbar. I mean, you have an app that uses the toolbar, right? Did you supply the layout to the toolbar? No. So we are not going to be able to use with ID to find the toolbar to verify what the title is. So what are we going to do if we want to verify that I set the title properly? Well, we're going to bust our hierarchy viewer. How many of you have used hierarchy viewer? Great. What this is you can take a look at not just the part of the UI that you set. So for example, when you run an activity, you do set content view, and then you give a layout, and that's the part that you define. It actually shows the whole UI that's being rendered. So you can see things that's kind of beyond your control. In our case, we can see that there's this text view, which has my awesome title in it, and that's the view that we want to verify. But the problem is, this guy doesn't have an ID, so how are we going to look for it? Well, fortunately, we can see that this is a child of a class that is of the type toolbar. So we can combine matches to pinpoint this view. Let's see how we're going to do this. Well, first of all, I have a helper function that helped me find the toolbar title. And the reason why I have this helper function that's match toolbar title is because that way I can reuse it, right? If I have multiple tests that I want to find the toolbar title and match it, I just need to write it once. So here is kind of the magic, where all of, that's the Hemcrest matcher. And then I will look for something that is assignable from text view, meaning I'm looking for a class that is a text view, or a child of text view, like maybe it's a button, but in our case, it's a text view. And then, because we have an OR, so we have to satisfy two conditions. The first condition is the view itself is a text view. The second condition is that that view also has the parent that is of type toolbar. So we are trying to translate what we see in hierarchy viewer into the matches. So with all that, we will find that particular text view, and then we can go ahead and do the match with text so that we can verify that the toolbar is displaying what we expect it to display. So far, so good? OK, good. Exercise this much of your body. But even though there's a lot of matches and you can combine them, there are times that we want to write a custom matcher. In fact, we're going to change this code to use a custom matcher. And it's not just for demoing purposes. The reason why I want to change it is because when you are doing that trick that I showed you, that you use the hierarchy viewer to look deep into a view, it may change, right? This is not your code. This is probably the support library if you're using AppCompat, right? Today, the toolbar display it by having one single layer, so you can use with parent to pinpoint your view. Tomorrow, things may change. It may get nested inside a linear layout because, well, they don't have to explain to you why. They just want to do it, right? So to protect yourself from those changes, it's much better to use a published API, right? Because when you are sneaking into the view hierarchy, that's not a part of the public API, and they are allowed to change it. Whereas, for example, here, we are actually going to use the toolbar.getTitle function. That is a part of the public API of the toolbar object. So instead of using all those match parent and all of and whatnot, what we're going to do is, this part is very similar. Well, this is actually just a function view toolbar title. But what we have is that I have written a custom thing called with toolbar title. So this is the dense code coming. Can everybody see it? OK, that's good. So what we have here is something called a bounded matcher. This is, again, I think it's actually Hamcrest. What happened here is that I'm saying that I want a view matcher that is specific to a toolbar, which is why there's a generic that I pass in the toolbar class. And when I want to see whether this matches safely, I will go ahead and call the toolbar, which is passed into me in this function because of this generic. And I'll call the function getTitle, and then I will match it with a test matcher. So test matcher, if you can see here, is of matcher class. So the previous slide, the is, that's the, this is kind of confusing, is, that's the matcher. So we're passing a test matcher, and the reason why I did it this way is because you can also pass in a different matcher, so you can also do something like starts with, ends with, contains, so it's much more powerful than if you're just passing a string. So those are all, again, Hamcrest matcher. You don't actually have to write the function starts with. You can just pass it in. So with this, since I just swap it in to my helper function, then I'm done, right? All the code that I'm trying to verify the toolbar title will now use the getTitle function. So this is how you write a custom matcher. Well, at least in this particular case, because what I want to do is I want to verify the toolbar object. So by giving it as a generic, I can have access to the function, so I can verify. So I've also written matches, for example, that I can verify the text color of a text view. So for example, Espresso, you can do the with text to find out what is printed out, but I want to know what color it is. Text view provides that you can use the, you can ask it to get you the current color. Right, so you can then wrap it inside a bounded matcher, and then in the match safely function, call the get current color function. Yes, I already covered that. Again, there's a full example. There's even a blog post if you want to read again what it's actually what I just said. But if you want to read in prose, you can go ahead and do that. Now, something more interesting. On data, has anyone used this matcher? What does this do?
Checks in your recycle view list view item.
You are half right. It checks the list view, but not recycler view. So we'll get to that. So yeah, so on data allows you to check on the list view. So for those of you who have not written it before, you may be wondering, why do you need a different thing? So the problem with, well, the problem is the way list view is done is that the views comes in and out as you scroll, because it's using the same views, but just swapping in new data to display. So you cannot just say, oh, I'm going to look for the view with ID list item. That is not going to work. So the formula for using on data is similar to the on view if you compare it side by side, except you have some extra things like called data option. We're going to get through an example, and it's much easier to understand. So one big thing is instead of a view matcher, you have an object matcher. So the way on data work is that it will, instead of look for a view, it will look into the data, essentially your array. For example, if you're displaying an array of strings, it will look for strings rather than views, like text views. And the data options, I hope you can see it, is things like in adapter view. So for example, even if you just blindly look from the data, but you have multiple adapter view, multiple list views in your app, then it doesn't know which one you're trying to match. So you can give it a matcher. So this time you can do, for example, in adapter view with ID list, outer ID.list. And you can also do things like on child view. So maybe you pinpoint that particular list item, but then it has two text views and an image view inside. So you can use on child view with ID, r.id.image, or something like that to do further matching. Here's an example. I have a pretty benign looking list view. And what I'm going to do is that I'm going to look for item 27 and verify that it says 27. So right off the bat, that's a problem, right? I can't see item 27. But the beauty of on data is that it will scroll for you. So that's yet another reason why you want to use on data. Just a very quick kind of like how the app is set up. I have a array that is the data that is of type item. So I made 30 of them, and I iterate, fill it in, and I use that to initialize my list adapter. And the item is pretty simple. it has an integer, and then when it needs to be displayed, it displays the value of the integer. So now, when this is, I guess, more complicated than I initially said. So there's also an on-click listener. So when I click on an item, it's going to display it in the footer, just because we are writing a demo app. So now we go back to the test and say, let's run a test to verify that before I click on any list item, the footer is not displayed. I click on one of them, and then it will display with a matching number. So that's English. And translate it into Espresso. I said, before I click anything, so in the beginning of the function, I want to find, this is the footer text view, on view with ID text, check that it matches that it is not displayed. Okay, so it's very similar to what we did earlier of the not enabled. Not is enabled. Next, we're going to use the on data with a value 27 to pinpoint that particular item in this particular adapter view in case there are multiple of them, and then we'll perform click on it. Once we are there, we repeat what we did earlier, except this time we actually want to make sure that it has the proper text and it is displayed. So far everything looks pretty good. Just one tiny thing, with value is not an Espresso function. You have to write it. Our best friend bound matcher here again. This time, instead of bounding it to a toolbar, we're binding it to an item. So I pass it in a value for 27 that I'm looking for, and then it matched safely. I'm going to see that it matches to the item. So that's what Espresso goes through. It looks for an item and say, hey, are you 27? Are you 27? And if it's not, it just keeps scrolling and keep looking. Good? All right. Recycler view. So yeah, a gentleman here already mentioned it. So this recycler view looks pretty much the same as our list view. However, you cannot use on data with it. Does anybody know why? Good. I'm going to teach you something. The reason why you cannot do it is that recycler view is actually a view group, not an adapter view. And even though it looks surprisingly similar, under the hood they are actually very, very different. So when you're working with recycler view, you're actually going to go back to use on view instead of on data. So let's go through an example. Here is the same test, functionally, right? We verify that the footer is not displayed, and then we are going to click on the item and then verify that it's displayed. However, the meat of it is completely different. We start with on view with ID recycler view to actually find the parent, and then we go ahead and perform this really, really long function, which is available to you in Espresso. So in the recycler view actions, you can use these to pinpoint items. So in our case, we are calling the one at position. So we say at position 27, click on it. So that's already different, right? Because before we're actually looking inside and looking at the item. There are other things that you can use. So instead of using the position one, no, okay, I'm one slide ahead. So anyway, this is the equivalent of the other of an on data case when you use it in a list view. Here. I hope it's not too low. So besides using this function, there are other matches other view actions that's provided for you in the recycler view actions. So instead of matching the position, you can also match it in the holder position or in the item itself with a matcher. So this gets a little bit confusing because here we're looking at the position, but here what we're doing is still going through all the views and then trying to match the view. So you'll probably want to kind of go through the recycler view documentation and just see what it does. Again, examples. I love putting on examples because I want you to go home and actually download this and muck with it and change it a little bit, like try a different view action and see what happens. So this is available. Idling resource. Who has used an idling resource before? 3 hands. OK, so we are really getting to the point where I'm showing you something new. That's cool. So idling resource, if you remember very, very early in the talk, when I was telling you that Espresso knows to wait for the UI thread to be idle before it goes and click buttons. But there are other things that's happening in the app that you may want it to wait as well. how do you tell Espresso? Idling resource is the interface that you need to implement. And for some reason, it's really confusing to people. So I have done multiple blog posts on it. So we're going to go through one example in this particular case. Again, that's what I said. Espresso has a notion of idling. And these two things are the things that Espresso is watching for. We are going to go through an example where, say you have an intent service, and you want Espresso to wait until it's done. So what happens is this. In your app, you have a button that says do something. And instead of doing it in the activity, because it's long running, it goes off to ask the intent service to do it, and then the intent service sends back and say, yay, I'm done, and you can update the UI. That's a setup. And this is the code for the actual idling resource. So it's an interface, and there are 3 functions that you need to override. The first 2 are kind of boilerplate. It needs to get a name, because when you're registering your resource, it needs a key, basically, so that it can keep track of them. So usually, I just give it the class name. And then there's this callback. You're just stashing away the callback that at some point Espresso will give you a callback so that you can use in this function. So is idle now is the meat of your idling resource. You're going to, basically Espresso, after you register the idling resource, Espresso is going to come along and say, hey, are you idle? By calling the is idle now function, and you return true or false. In our particular case, we are trying to make sure that the intent service is not running. So in the next slide, there's going to be actual implementation of this. But let's say we have this magic helper functions that will tell us whether my intent service is running or not. And I say, if it's not running, then it's idle. When it's idle, I can go ahead and call this callback that I stashed away here so that I can notify the Espresso and say, it's idle, go ahead and do your things. So that's how idling resource is structured. So like I said, this is the magic helper function. Basically what we're doing is we're querying the activity manager for the particular name and make sure that the one that we are looking for, well, it's there, then it's running, right? If it's not there, then it's not running. It's a little bit confusing, right? Because then one level later, we negate it. So this is, if it's running, if I can find it, then it's running. So once you have defined your idling resource, then you need to register it so that Espresso know to actually ask this particular idling resource, like, hey, are you idle now, before it moves on. Like I said, very confusing topic, so I've written a lot about it. One other thing that I want to mention, because even I forgot, is that Espresso only check the idling resource if it's trying to do a view action or a view assertion. So I have done things where I am like, oh, I registered an idling resource, and then I'm going to go check some Java level thing. And then it was not actually waiting for stuff to finish, because what happens is that it inserts itself in the view action and the view assertion. So things like on view and click and matches, and those are what I'm talking about. So make sure that you are waiting at those points. If you think Espresso is waiting and it's not waiting, it could be because that you're not at the point when it's acting on a view action or a view assertion. Good? OK. All right. So now this is the point where I think things get really interesting. Espresso alone allows you to click on things and exercise code paths and verify things. But a lot of the times, as Android developers, when we want to test, it's more of an architecture problem. For example, we are going to go through an example where your app depends on the current date. How am I going to verify things? It's going to change every single day. So Dagger and Mockito allows you to set up a test environment that's predictable and repeatable. Dagger does dependency injection. That's a fancy term. All it means is that in your constructors, it's going to have a central repository to grab objects from. This way, you can have one repository of objects for your app and a different one for your test. Oh, wow. I just said what I wrote on my slide. That's pretty amazing. And Mockito is what you can use to provide those objects in your test so that you can control, for example, today's date. So this is kind of the basic formula for Dagger 2. Dagger 1 is different. What we need to do is, when I say a repository of object, what I'm talking about is a component. So here I have defined a component, and it knows that it can inject fields into the main activity. And I have two different subclasses. The application component, which is empty, meaning that it only it only injects into the main activity. And there's a test component that it will inject also into the test. And they are singletons because we want the same object to be used in app and test, so that when you change it in your test, your app is actually using that object. And here, the way you define what's inside your component is by these annotations. So for the application, we will have a clock module that will actually give you today's date. And in the test component, we'll provide a mock clock module so that I can control what date gets used. And I have given you also a beautiful diagram in case these doesn't make sense and what my explanation doesn't make sense. So this is just a graphic representation of what I just said, right? So here I have an application component which injects into main activity, and it has a clock module that knows how to provide a clock. And then in test, we'll have a mock one, and it will be injecting into both the test and the app. In the application, in your onCreate function, we are going to go ahead and instantiate one of these application components. The reason why it has such a funky name is that what you define the application components is actually just an implementation. Dagger will go ahead and do some code generation behind the scene and generate this class for you. Then you can go ahead and use this class and create an application component and stash it in this variable. And then we are actually also going to have a set component function because we're going to use it in tests. So what happened is that when it's test, actually it's probably going to be in the slide, just, maybe I shouldn't get ahead of myself. So let me just get into the next slide. So here, what we are going to do is that, so stash away what I just said, the part that we have an app component, and then we also have a set component function which is used in test. So in test, we are going to have something different for the function getNow. So in the app, have you used Joda time? That's a really nice date and time library for Android and for Java. So date time is what the Joda time will provide you. If you just give it with no parameters, it will give you today's date and this exact moment. In the test, what we're going to do is we are going to go to the view that has the ID date. This is actually a text view. And then we're going to verify that it will display the text 2008-09-23. If you don't use Mockito and you don't have control over the clock, well, then every day that you run this test, it's going to display a different string. So you can't really test that. So that's the power of using Mockito and Dagger. Dagger allows you to provide a different component to your app and your test, and Mockito allows you to mock the behavior of that class. So if you look at it again, the syntax is like when this function is called, then return this particular object. You don't actually need to write a function to define things. So it's all very fluent, and you can define a lot of different things in Mockito. Again, blog post, repository. This one is slightly different because I actually have a video course that's pre-recorded that I actually stepped through one particular example. The example is using shared preferences. Because when you think about shared preferences, it changes the state of your application, right? So maybe first time you open this app, someone say that my favorite animal is cat. And then the second time you come back, you want to show that it's a cat, but you don't know whether it was provided or not. And you don't want your test to modify the state of the app, right? Because then it's persisting, and the next time you run, you don't know whether it's going to be having an initial state or not. So using Dagger and Mockito, you can also do things like that. You can provide an in-memory shared preferences, which every time you run it, it's going to start from fresh. Instead of go and delete your database of the app. So that is actually a course that you have to pay. But since you are all here, there's a coupon code BBQ. If you go there and you check out, you can put that in for a discount. So in summary, we have gone through a lot. Hopefully you still remember, despite all the drama, of what we learned today. That's the basic formula of Espresso, where we have a matcher, a view action, and a view assertion. With that, you can combine them to pinpoint a particular view. We were using the example of a toolbar. And then we actually use the same example, but this time write a custom measure because we actually want to use the toolbar.getTitle function. After that, we went through how do you test something in the list view and the recycler view, which surprisingly is very different, even though they look very similar on the surface. Then I went through an example with you on the idling resource. And finally, I think most applications will need to go beyond just using Espresso. And Dega and Mockito are two other libraries that is often used in conjunction so that you can set up your test environment and have control over the data. This is some bonus. I actually wrote this app and open sourced it in August. It uses the Nearby API, and it's completely on GitHub. You can also download it on the Play Store if you want to just check out what it does. But I'm going to explain to you what it does is that you will click on that button that says Google Plus Sign In, and you will sign in. And then you will open this screen to find nearby devices that also has this app, and then you will exchange some information. How on earth are we going to test that? How are we going to test Google Plus login? How are we going to test nearby devices? Well, guess what? This app has really, really high test coverage because of all the techniques that I showed you. I use Dega and Mockito. So I actually have a bridge, what I call, that instead of calling the Google API client directly, I call through the bridge. So I call on connect. Anyway, the connect function of my function through the bridge, and then I can use Mockito so that, oh, if someone called the connect function, then I'm going to capture it and then call the on connected function and spit it right out back and run their callback for them. So it's actually really advanced, so much more advanced than what we have gone through before. But it's completely open, so go ahead and study it. And there are also beyond that, beyond Espresso testing, it also has JUnit testing, which is testing on the pure Java level, mostly on the models, right? So if you're, by model, I mean in a POJO, like a Java object that stores different fields in it, so you just make sure that if you initialize it this certain way, it has certain data in it. And then I also have what I call UI-less instrumentation, meaning that it's instrumentation in the sense that you still have context, you still have access to your standard Android libraries. Whereas when you do JUnit, you cannot do bundle, you can do all these things. But there is no UI. So what I'm using that for is exercising the database code, essentially. So I'm creating a test database, and then I'm storing things in it, and then I'm calling some function that will read the database and then give me some, I'm trying not to kick anything. Give me some statistics back. So that's that example there as well. And then, of course, there's a lot of Espresso going on. So go ahead and play with the app again, download it, change it, and see what it does. And if you don't think this is awesome, and you don't trust my word, I have someone who said that there is some seriously badass testing kung fu on display. Thank you. I agree with him, though, but you have to go check it out and see if you agree that there's some serious badass testing kung fu on display in this repository. With that, thank you very much. And these are a lot of the different resources that we've covered already. The first one is the slide deck, and then the rest are the example code that you can find on GitHub. And also, I actually also author video classes on Pluralsight, which is a subscription-based service. You can also check that out, and there are other things I teach. And then other places you can find me on the internet. Sorry, list is really long. I have 2 newsletters. I have a blog. I have Twitter. I have Google+. So plenty of ways to find me. So one other thing that I didn't have time to add slide for is that a lot of people tell me that there is so much effort in doing testing, like why would you bother? So I just want to give you like one reason why I do it myself. I work with startups, and a lot of the times they will have a server team that need to implement some server change before I can implement the Android UI change. And they are slow. They're usually slower than, like, you know, we'll do a sprint, and then they're like, oh, let's go and implement that. And I'm supposed to be implemented in that sprint, and I'm like holding my breath and waiting for them to implement the server change. Well, no more, because I have Mockito. I actually use Mock Web Server. So what I do is that I have my test, and all I need to do is agree on the the JSON format with my server team. And then I'll just mock out whatever I expect the response from the server is going to be. And I can go ahead then write the UI code before they are ready. And I can then test bad cases, right? What if I get a 500 error? Like, what will my app behave? You don't usually test the happy path, and it's really difficult. Like, how are you going to do that in a real-life scenario? Are you going to like, ask them to shut down the server so they can test your 500 case? No, right? But in our case, if I have set up my testing infrastructure, I have complete control of what my mock server is going to do, and I can go ahead and write my app without the server ready by testing. So testing in quote. So that's actually how I use testing, which, of course, then the side benefit is that it is actually automatically running, right? So I can also catch regressions. So sometimes I will change one thing in my style, thinking that will be all good, but then Espresso will be like, yeah, you said the color is supposed to be gray. It's actually purple now. So I can also catch regression because I have written my test. So I almost look at that as a side benefit of like the testing part. Like the part that I really like is the fact that I can mock out the server, and then I can go ahead and write my app without my server team being ready. So with that, thank you very much. Thank you for tolerating with my kicking of the stand. So, thank you. Feel free to leave, but I can also take some questions right now. Yeah. Okay. So the question was, because of technical difficulty, we were interrupted right at the dagger point, which is kind of tricky. So he wants to know how you can set up dagger 2. If you go to my GitHub repository, there is a sample project that is called Android-test-demo. It uses dagger 2, Mockito, and Espresso 2. And that's a blog post that's linked from there in the README. So I hope that the blog post will explain pretty well, kind of step-by-step how you set it up. Yeah, you can refer to that. Yes, question?
Yeah, when you discuss the custom idling resource, I had a question. It may be due to bad application design or something like that, but it seems like there's a potential for a race condition if you're checking for whether or not a service is running, and that service is invoked multiple times from the test client. Is there a way to have like a named task on the idling resource so you can see whether or not the intent service has completed a specific request to fulfill an action as opposed to whether or not it's running in general?
Okay, the question was, can I improve the idling resource for the intent service? So instead of checking whether the whole intent service is running, can I check a specific task? I don't know off the top of my head whether intent service is queryable, if that makes any sense, that I can ask it what is running. And it's kind of not really Espresso specific, right? Because it's basically intent service specific. You're trying to detect whether your particular task is running. So sorry, I don't know. Sorry. Yeah. Question? So the question was, he has a view pager that has multiple recycler view on the different pages, essentially. And he will swipe and said that, OK, this one is the visible one. I want to test it. But secretly, the other recycler view is still hanging out because that's how you can swipe it back in. And he's asking, how can I make sure that I'm verifying the one that I want to verify, right? Does that sound good? Give them different IDs? Does that work?
We have a collection of pages, so from time I can find the attach different IDs.
Oh, I see. So they're dynamically, they're dynamically attached, so it's not going to be using the IDs that is from the XML file.
One thing I've tried is an adapter, give dynamic tags and then use with tag.
OK. He said he uses dynamic tags. I think that's reasonable. I mean, I was going to suggest something similar, right? You can just issue UUIDs essentially to them, and then you can verify them. But that's going to be random, though. So if you have something that's predictable, then you can go look for them. I think you are doing something quite very reasonable. I mean, there may be better ways, but I cannot think of it right now. Yeah. Another question.
Just practically, can you tell us how much time is spent on writing these days? Because as I look at it, it is at least twice more complicated than writing the code itself.
So the question was, get real now. How much time did you spend on writing your test? So it's true. Like the setup, like you actually add some complexity by using Dagger and making it so that you can mock and whatnot. I have not clocked the hours that I'm strictly writing tests versus I'm strictly writing the app, because the way I describe I work, right? I use the test to drive my app. Like I will mock out the server response and then go implement something in the test and run it. So for me, it's a very integral part of my development habit, essentially. So I can't really tell you specifically how much time, but what I can tell you is this. There are times when it caught things that I would not caught on my own. For example, what I did was I did a map fragment, which I was inflating dynamically rather than statically for some reason. And when I upgrade from Google Play services, I don't know, 6.5 to 7 or something, some version, it broke. And usually I don't go to the part of my app that has the map on it because it's kind of not on the main use case. But my test caught it right away because it crashed. So I feel like the value is very hard to quantify. Like, what if when I didn't have the test, then it will probably be launched with that crash, and people will yell at me from the internet, and then I have to go find out. So I don't really have a hard number for you, but I find it it's worth doing. I mean, I think that's the short answer. But and you have to trust me on that because I don't have data for you. So, cool. Well, thank you very much. I'm going to stay around a bit so we can chat off stage as well. Okay? Thank you.